Good afternoon. Welcome to the California Ornithological Society. Just kidding. My name is Nick Lair, president of the California Avocado Society. Thank you for joining us today. Before we get underway, I want to ask you here, if you're here in person, please silence your phones. And if you're joining us virtually, please mute your microphones or we will do it for you. So whether you're joining us in person or virtually, we appreciate your support. If you're not a member of the California Avocado Society, I strongly encourage you to join. We've been operating for over 100 years, and our ability to support the avocado growing community is contingent upon our membership. I'm very excited about our presentations today, followed by a panel where you can ask our experts. I want to thank Gonzalez, here to discuss true organic fertilizers, as well as Eddie Grangetto of Grangetto's Farm and Garden Supply. Thank you, Eddie, for sponsoring the seminar. I also want to thank our other seminar sponsors, Fruit Growers Labs and Senagro. I especially want to thank our foundation sponsors. These organizations have fully committed to sponsoring all our seminars and meetings, and I can't thank them enough for helping to prop up the California Avocado Society. Del Rey Avocado Company, Nutrient Ag Solutions, Calavo Growers, Brokaw Nursery, Westphalia Fruit, Index Fresh, Westpac Avocado, Ag West Farm Credit, and American Ag Credit. Thank you, thank you, thank you. Now, without further ado, Eddie.
Well, thank you very much. It's quite a pleasure. You know, I was thinking the other day, how do you get to be an expert? And I think it just as you get older and the rest of the experts drop off the face of the map, you move up. And so you're down to me now. So, but I want to thank the society. Thank you very much. And I'd like to especially thank Gary for helping and putting together this presentation. I would hope that today you all walk out of here at least with something that you can put into use immediately. I've been to quite a few of these meetings over the years. Every time I go into the Grove, I'm surprised. And, you know, it's a constant battle against the elements, the importers and this and that, and it's a process of learning all the time. So I hope I can offer you something today that's valuable. Okay, so Gary asked me to talk a little bit about why in the world would we want to inject fertilizer into the irrigation system for avocados. What I was saying is that if your roads are laid out properly, then your irrigation system probably is going to work much better because the pipelines are in the road. And years ago, we had a couple of people here that were very, very good on laying out roads. And they almost could do it without a soil conservationist going out and putting out stakes and doing all these other things. And even to this day, those groves are doing very, very well because they were set up right from the get-go. And that's why it's very important, if you are putting anything through the system, start with a system that works. Nowadays, you know, it's true that roots aren't stupid and water is very, very expensive. And one of the things, whenever I meet a grower, the first thing I do is say, have you had an irrigation evaluation? And this is done by many different outfits, but we used to always go to Mission Resource up in Fallbrook. They had a program. There's now a Mission or a RCD out of, I think, out of El Cajon area. They've kind of divided up the area, but it's so very important to get an evaluation of your irrigation system. And when you are putting fertilizer through the system, it's going exactly where it needs to go, into the wetted area. And that's so important because I don't know if you've ever thrown fertilizer out by hand, but the longer you're out there, the sloppier it gets. And I've been out before where I've looked at the trunk of a tree and there's a perfect little ring around it. And I'm going, well, that's fine, except you're supposed to have this spread out over the entire root zone in the path of the water. Well, if you're putting it through the irrigation system, that's exactly where it's going to be. This is a tree on our property. I like to tell everybody our trees look like this year, but this is this year. This tree's loaded. I have no idea why. I wish I could tell you. I wish this was all the great culture that that we've been doing. This is a tree on the extreme perimeter. It's a Carmen, I believe, which we only have about 5 of those. And why it's loaded like this, but this is what you're looking at. And Gary, gave a very good headline to this. This tree is going to need a lot of nutrition. So when you're looking at your trees, certainly if you've got a tree like this, you've got to fertilize to the crop. But way before that, you're going to have to determine, what do I really need for this season? And I know I've got a lot of people that they go, I do leaf analysis, comes back the same every year. So I just do the same program every year. And it's always good. And then I ask them, well, how's your production? Well, we get 6,000, 7,000 pounds per acre, which is probably the average of California. I go, well, maybe something in your nutritional program that is not allowing you to get up into the upper levels. Years ago, it used to be those very best growers, the legacy growers, 15 to 20,000 pounds before high density. And those were the guys. And now it's a shame because a lot of people think, well, we're getting 15, 20,000 pounds, but we've got 400 trees per acre. It's not quite the same. The other thing is that a lot of these trees now, they're very, very good producers. They have rootstocks that are tolerant to Phytophthora. They have salinity tolerance. And a lot of these younger growers think they're, really, really the thing. And it's interesting because, you can hand them 400 trees per acre and probably get a chimp from the zoo down here to take care of it, and they'll get the same production. But the important thing is that you get a leaf analysis. The leaf analysis normally done, taking 6-month-old leaves. I usually say the spring flush. So if I'm out pulling the leaves, usually from August 15th to the end of October, I tell people to pull the spring flush, 3rd or 4th leaf back from a non-fruiting, non-fleshing terminal. And you've got to get the right leaves. The other thing that's very important is you've got to take the right path through the grove. I was with a fertilizer dealer many years ago, and we were in a citrus grove, and he goes, I've got to pull some leaves here. And I thought, oh my God, I can't spend all day out here. Well, we drove down the center of the grove. He rolled the window down and was taking the leaves. We ended up with about 10 leaves, and this grove was probably 30 acres. That was it. You can't do that. You have to, if you've got a south face, or if you've got a north face, or if you've got something that's very unique, break that up. Sample from those quadrants and list those as A, B, C, 1, 2, 3, whatever it may be. When you send it to the lab, the leaves always go in a brown paper bag. Don't put them in a plastic bag. And then the other thing that's very important is you got to understand what you're getting back from the lab. Now, these labs all speak different languages. And I know a little bit about some of the labs, but I look at these other ones and I don't understand any of it. So you have to have a great relationship with your lab. I tell growers all the time, you pay for a CPA, you pay for a lawyer. Why in the world would you not have a good relationship with your laboratory? Have those guys in your corner so you can call them and ask them. Don't listen to me. I don't know what I'm talking about. Have those guys in your corner so you can say, hey, I've got this analysis. Can you talk to me a little bit about it? The other thing is that some of the analyses will come back in percentages with some of the more important elements, and parts per million with some of the micronutrients. Got to get an idea on how all that fits. When you talk about soil, I usually tell growers, hey, every couple of years, do a soil analysis also. Now, there's another thing. Sometimes the lab will give it to you in parts per million, but also there are some labs that give it to you in acre feet. And so you have to really understand how to read that so you know what to put on. But it's very important. There's also a lab that I'm kind of partial to because I went through their program a little bit, and that's the Kinsey lab. Kinsey's very, very interesting. His name is Neil Kinsey. He's written a book. He is on YouTube, and he is a follower of Dr. William Albrecht. And I wish I would have brought my shirt because I've got a shirt with his picture on it. Very interesting guy, and he zeroes in on base saturation. Now, there's a lot of scientists that say, well, that doesn't really mean a lot. But I can tell you that with the information that we get back from the Kinsey reports, I have seen a real improvement in people that use their analyses. And the nice thing is they'll give you a report that tells you exactly how much to put on. And it's just common product, no foo-foo products. So when you talk about liquid fertilizer, this is one of the things Gary and I were discussing for the presentation. The liquid fertilizer doesn't change a lot, and it's kind of the way it always was, but the regulations are horrible. So the first thing you want to make sure of, if you're on district water and you've got a water meter, make sure you talk to them about backflow prevention. They're always worried about something going haywire with the system. If there's a break, that fertilizer could be siphoned back into the system and somehow, kill 500,000 people. Well, unfortunately, you have to pay for that. And the bigger the pipe, the more it costs to get a backflow preventer. So make sure you look into that, because when you're trying to figure all this out, there's no doubt that liquid fertilizer, in my opinion, is the way to go if your system is set up right. But when you start throwing some of these other things in, sometimes it makes you scratch your head. Also, Gary had mentioned in the presentation of a spring-loaded check valve. So any of the systems that I used to fool around with, at the point of injection into the system, we would have a one-way check valve there. And that is to prevent the water from flowing back through the injector and doing exactly what some of these backflow prevention devices do. But if you do look into a fertilizer injection system, make sure you deal with somebody that has experience. That's very, very important. Again, check valves, stainless steel is, you can't go wrong. They're very expensive. But the other thing that we use a lot of is plastic. But you have to remember that a lot of these products can cause corrosion, and they can also react with water. Make sure you're talking to the right people. Corrosion in metals. Well, you can look at this and pretty much see that anything with metal can be attacked by a number of these different products. A lot of times I'm talking to a grower, and if he's got irrigation lines that have some metal, but he wants to use a liquid fertilizer, I'll always try and stay on the straight nitrogen side, and no sulfuric, no infuric, no phosphoric, and so on and so forth. However, you can also create some different types of products. Years ago at Grangetto's, when we were kind of experimenting with some of our liquids, and Leo probably has some stories about this too, we created quite a few different mixes that probably never got out to the grower because they weren't the type that you'd want. And, some of those, particularly when you mix in potassium chloride, can be so very corrosive that it can actually ruin stainless steel. So be aware of that too. The pH of the water. Yes, that's always important. And I had a little story years ago where we had a grower that I was going to help him clear out his line. So I went out there with a pump and sulfuric acid and started pumping it into a 3/4 inch riser, and it was going great. Within about 15 minutes, I looked over and the riser had just laid over like this because there had been such a reaction that it essentially melted in place. And I could have made so many errors with that, but you have to be very, very careful and know what you're dealing with. And if you have someone that says, hey, we've got the best liquid fertilizer since sliced bread, make sure you ask them all about it, because it may not fit what you're doing at all. And the first thing to start with, of course, is if you do have a pH problem where you have alkalinity that has raised the pH up in your water to 7.5 or more, you may want to think about amending the water even beyond what you're fertilizing. Safety data sheets. Well, you have to have these with everything now, and fertilizer's no different. So you need to keep these on site, and then you need to keep set in your office. So if you do have a problem, very, very important that the people can go to this and know what the first aid is for anything that may get in their eyes or on their skin. And you probably need to do your safety training with these also, probably on an annual basis, whether you're getting new employees or not, simply to remind them that if we have an accident, this is where the safety data sheets are, this is what we need to use. When working with acids, certainly you need to wear protective clothing, but the other thing you need to be aware of is that almost everything that we have in the liquid fertilizer world can cause a problem with your eyes. So having any type of protective gear, the more the better. And of course, once it's in the irrigation line, you don't have to worry so much. But when it's in a concentrated form, make sure the folks are wearing the protections, certainly the eye protection and gloves, and usually rubber boots for a good start. You don't want problems. And with all the regulatory issues now, boy, they'll be on you. And then once you get on the list of these regulatory agencies, you don't get off. Sulfur burners. There's probably only a handful of people that have sulfur burners. And I know very little about these, but generally these are used by the folks that are in the organic world because they can't put through sulfuric acid or infuric acid through their irrigation systems because it's not approved for organic production. This allows you to do it because you burn sulfur and then this is injected into the water to be able to create the atmosphere that will reduce bacterial growth, lower the pH, and do all the things that you want something like this to do in lieu of using sulfuric acid or other agents. So these are not cheap. These are expensive, and you have to know what you're doing with these. But once they're installed, the people seem to like them. And they look very impressive, too. So, having one of these, of course, this is brand new, and I'm sure, but after they've been out there for a while, they don't quite look like that. But no, they're very, very interesting for the organic folks. Injection devices. Well, there's a lot of those out there. And you've got differential pressure tanks, you've got Venturi devices. This one of those. Now, there's a lot of them that are bigger. This is a Mozzie injector. This is a little tiny one, but they're very unique, very interesting. People go, well, why would I use anything else? Well, there are reasons why. Positive displacement pumps are the type that essentially have either a diaphragm or a piston, and it just kind of pumps the fertilizer into the irrigation system powered by a gasoline engine, power takeoff from a tractor, electric motor, whatever it may be. This device too, this is a dosatron injector, and many of you are familiar with these. This is a water-powered injector. And these are so unique because many years ago, and my brother Kevin's very aware of this, Howard Hutchins had a very interesting injection system. But the problem is every time it would pump, it would expel a little water. This doesn't do that. And this is a small one. In fact, we even have these, you can put it on a cart and move it around in a greenhouse. The water flows through here. I don't know what the arrow is, but either this way or that way. And the fertilizer is pulled up here, and you can adjust it. So you can adjust the concentration here. You can also adjust concentration. In fact, I was just talking to them the other day. They've got one now that'll handle up to 400 gallons a minute. Completely water powered. So knowing how to get the fertilizer into the system is very, very important. The other nice thing about these, the dosatron, is it's a proportioner. So if you're growing in a soilless media, especially, not so much in avocado growth, you can adjust this for parts per million. So if you want to keep a constant flow of nitrogen going through your irrigation system all the time, whether the water slows down or speeds up, this will do it. Now, most of the time, for avocado growers, we just want to take this and put it out there. And we want to do it certainly in a systematic way, and we don't want to overload the system, but we have such buffering capacity and so much protection with the soils that we have that even if we overdo it a little, it's not a big deal. So we don't have to keep the 100 parts per million or the 150 parts per million. We can put quite a bit more in that. And of course, when you go out and throw it on by hand, as Dorothy and AC know, if you're throwing this stuff on, you're putting on 5 or 6 pounds of fertilizer at one time in the dry form. But that's another talk. So fertilizer, according to Gary, should be injected at 0.1% of the water flow rate. I don't know if that always happens. It'd be nice if it would. And he's saying that would be, one gallon in 1,000 gallons of water. I know when you get some recommendations back from Fruit Growers Laboratory on amending the water for alkalinity, sometimes they'll say put in 12 fluid ounces of acid per 10,000 gallons of water, or whatever it may be. And that is very important. But again, in the old days, and I think Leo was very familiar doing some of this work, they would send a truck out and the grower would be irrigating and the truck would just pump in the fertilizer at that point. And it was very, very worthwhile as long as the grower knew how many trees they were doing, and it worked very well. And then go down the road and do it for somebody else. So what I'm saying is it's good to know what you're doing, know the limitations, know how far you can go, but the precision that we might need in, say, a nursery situation is very different than what we're looking at in a growth situation. Now, of course, I've made a few mistakes out there, and that's the other extreme. So a batch tank, and this is probably one of the oldest pictures of a batch tank you could ever find, but you've seen these, and these, again, are water-powered. And so what you've got is a vessel, the tank, that you put your fertilizer in. It can be dry or liquid, and this tank can be 5 gallons, it can be 100 gallons. It doesn't matter. The operation's the same. And what you do is you simply channel a portion of the water flow through the tank. It mixes with the fertilizer, and then because of a differential in pressure, and if you look at it, you've got the 2 hoses that are connected to the 2 inlets and outlet, and then you've got a valve in between. Well, if you turn that valve in between down, that's what creates your pressure differential. And what we do is, years ago, I used to ask these growers, how do you know when all the fertilizer's out? Well, I open the lid and I taste it, or I put a dye in it, and then, when the dye's gone, well, how do you know? Because you have to look at the sprinkler to see when the dye's gone. All these crazy things. But the best way to do it is knowing that any of these tanks all work on the same formula, and that's 6 times the capacity of the tank. That amount of volume is what it takes to disperse all the fertilizer. Well, we put a flow meter on it, so we know what's going in has to come out. So if you have, say, a 5-gallon tank, multiply that times 6, that means 30 gallons needs to flow through that tank before all your fertilizer's out. And the way these work is, a lot of the smaller tanks, the more popular ones are like 30-gallon tanks. You can usually put 3 bags of fertilizer in those max. And so what happens is, whether you have 1 bag of fertilizer in there or 3 bags, they start out very, very concentrated, become more and more and more dilute, until finally you're running just clear water through it. And that's why the flow meter is so important, because if you start this, let's say you got a 10-hour irrigation set, you got to know how long it is for this thing to empty out. And you don't want to turn it on at the beginning of the set, because all your fertilizer is going to be leached out. So these are great, but you have to understand them. And they work very, very well. Inexpensive, somewhat, because they're not they're not really too inexpensive, but the way that they operate, and because you can buy one usually for the life of the grove, it's not a bad way to go. But again, you can put liquid fertilizer, or you can create your own liquid fertilizer by putting a dry soluble product in it. Okay, here's our little Venturi device. This is the Mozzie. Maybe other ones out there, but this is the one that's most well known. It's something like a Venturi in a carburetor, where it simply has water going in one side, coming out the other. And if you see this thing, it's kind of slimmed down, creates suction, pulls the fertilizer from your container. And I've had people say, why would I spend all that money on a fertilizer injection system when I could just buy this? The problem with these is that it takes a certain amount of differential. Now, when we talked about pressure differential with the other batch tank, sometimes depending on the size of your irrigation line and the pressures and such, you can get away with maybe a 15-pound differential, which you can afford most of the time to lose if your irrigation system is set up right. This little device, though, sometimes can take 30 or 35 pounds. Now, I've had people where they wanted, they got one like this because they had read a brochure or something. And so when they created the differential, they had no water at the top of the hill. And so you have to make sure, if you're going to be looking at a Mozzie, make sure you call the company and talk to them. They've got engineers on staff, but don't think that you want to get the big one. If you're not quite sure, start with the smaller one. But they are pretty handy. And for a lot of the flower growers, where they're injecting here, and there, and they simply have a 5-gallon bucket and they're moving it around, it's pretty interesting. The other thing is that you would think, well, gosh, to be able to do this, I would probably have the differential where I would have a greater amount of pressure at the end rather than the beginning, but it's exactly opposite. So you can see this in this diagram, but as it pulls the material in, it mixes with the water and then flows out through the irrigation system. The other thing is that the stock tank that you're pulling from can be a 5-gallon bucket, a 30-gallon drum, whatever you want, and that can also be diluted to any level. So it's very low tech, but it really works in some situations. The difference in pressure, we talked about that, creates a vacuum. The hookup is very, very similar to what we had with the batch tank. So you've got the valve, as you can see, coming down, and then you've got the Mozzie, and then you've got the valve coming up. But the differential is created by the valve at the very top. So as you throttle that down, that's what kicks the differential in. And then you can, if you have a clear tube coming from the Mozzie, you can see that material just start to move. And it looks like magic. But remember, as you do that, your line pressure is going to be dropping. And so you want to make sure, if you see, boy, let me crank that valve down and create that differential, maybe 50 pounds, you're not going to get any water out where you need it. So be aware of that. They come in different colors, I think, with different materials. Again, Mozzie's got a great site. Talk to those guys. This, again, shows a couple of different types of injectors. The batch tank, if you will, or pressure differential tank is the green one. And then the other one, I think, is another manufacturer. It's a little different, usually for the home and garden line more so. Positive displacement pump, we talked about those a little bit. This happens to be, I think, a water-powered pump similar to the Dosatron, but there are many different styles of positive displacement pumps on the market. They've been around for a long time, and now they're probably on an average of $2,000 plus by the time you get the motor and the engine and the injector. Yeah, this is an example of what some growers are still using, particularly grove management companies, where they'll have the fertilizer in this tank. They'll pull up to a place in the grove and simply hook on to a riser and pump the fertilizer in as they're irrigating. Very similar to what we were talking about before. Again, it's kind of a system that I guess real horticulturalists kind of frowned upon. But if you're trying to get around, you're trying to get the fertilizer out and you're doing things right, meaning you're going to probably inject this fertilizer the last third of the irrigation cycle. You're keeping an eye on everything. Many times you can pull up and you may have a 10-hour irrigation set. You can pull up on the 6th hour of that after you've checked everything and there's no breaks and everything's working properly. Spend 10 minutes pumping the fertilizer in, and then you're off to the next place. So it really has a place in what we do, especially if you're pumping it in on a system where many times we say, let's start fertilizing avocados in March, and we may end up finishing up at the end of October. And within that, we're doing it maybe every other week. Well, if you can zoom around and be able to apply fertilizer in this manner, it's very effective. Fertilizer suitable for injection. Of course, everybody loves urea, and urea is a fine fertilizer. You know, one of the things, of course, I'm not supposed to step forward, but one of the things that people ask me all the time is, how do I know the fertilizer is going from here to there? You can use an EC meter, and an EC meter just measures the conductivity of the water. And so what you do is, except for urea, doesn't work with urea, but works for almost all the other fertilizers that are salt-based, you simply start injecting and go down to your last sprinkler and start testing the water. And when this thing comes up, you know your fertilizer got there. When it comes down, it's gone. So this is a very simple way to give you confidence that what you're doing is working, because a lot of times people go, wow, you know, I really need to run this injector for several hours because I want it to be dispersed properly. Doesn't make any difference. If your irrigation system is set up properly and you don't have some break or something very unusual and it's all balanced the way it should be, it doesn't matter if you inject in 10 minutes or 10 hours. It's going to be spread throughout that irrigation line, especially if you have pressure regulators and pressure compensating sprinklers evenly. So trying to stretch it out to 10 hours, it doesn't make any difference. But that's a whole nother discussion. Now, these are all forms of nitrogen that you can use. Some of these are liquids, some are dries. Unfortunately, we have ammonium nitrate on there. We can't do that anymore because now they have it coated. That was the other thing. Somebody said, well, how are you going to introduce yourself for this program? You don't want to talk about being a fertilizer salesman, because, you know, just recently, old Scott of Scott and Lacey, the fellow that went to prison for killing his wife, was a fertilizer salesman too, and now he's coming back. So I don't want to say anything about being a fertilizer salesman, but the ammonium nitrate we can't use anymore because they used that as an explosive years ago, and so now it's coated. But some of these other products we can solubilize and put through. And if you use liquid, of course, you don't have to worry about it. The other advantage is that if you have something like calcium nitrate that's got 19% calcium, very soluble, or CAN 17 has 8.8% calcium, and that calcium is so much more soluble than putting out gypsum. Phosphorus, yeah, you have to be careful, because if you do use some forms of a neutral phosphorus product, you can get into a lot of trouble if it reacts with our river water. And this can plug up a system very quick. But again, this is why you need to talk to your fertilizer supplier and your laboratory, because you can work around this. But you have to be careful with phosphorus sometimes. And there's many different sources of that. There's dry sources and liquid sources. There's soluble sources. You know, many times we'll use just phosphoric acid. And again, as Leo knows, there's a couple of different forms. You've got a white food grade, which is very pure. And then you've got this green acid that has all kinds of impurities, but it's much cheaper. And sometimes people like the impurities. Of course, a lot of those are heavy metals, and those can cause problems. But phosphorus, again, is all part of a well-balanced fertilizer program. Potassium, again, a lot of different sources, dry, liquid. There's some terrific products, such as potassium thiosulfate, that is a liquid. It's chloride-free. It's a wonderful product. You can blend with it. There's good old potassium sulfate, which people can put through their irrigation systems, but there's limitations. The potassium nitrate, the 13046, is probably the Cadillac of fertilizers, but it's so very expensive now. It's kind of off the table for the standard grower. And the muriate of potash you want to be very careful with, although there are some growers that are using some of that now because they're saying, look, even if I put on a little bit of the muriate of potash or potassium chloride, it's still well below the amount that I'm getting through my river water. And the other thing is the muriate of potash is very, very soluble. We can blend with it, but it's very soluble, whereas the sulfate of potash can tie up in the soil and may not be available to the plant. Compatibility. Yeah, you have to be very careful. Now, a lot of this is more dependent on the people that mix their own liquid fertilizer. So many times on some of the bigger operations, they'll have 3 tanks. They'll have a tank for their nitrogen and their phosphoric acid and their potassium product, whatever it may be. And so right away you go, well, can I put some of this in that? So I don't, can I put a chelate into an acid? No, you can't. There's many limitations on this, and you don't want any explosions. You don't want any problems. One time years ago, I had added some sulfuric acid to a potassium chloride deal, and it created this wonderful gas that was very deadly. And luckily, I wasn't hanging my head over the tank, but I got a pretty good whiff of it. And yeah, you can make a lot of bathtub experiments go haywire quick. The other thing you don't want to do with liquid fertilizer is not clean out the tank. Holy cow. Somebody's always in a big rush. Is your tank clean? Oh, we're ready to go. They go out, they pump it in, and then they've got 500 gallons of mayonnaise. And you can't get it out. And my gosh, we went through some of that too. How do you clean it up? So understand all the compatibility issues. Talk to your fertilizer supplier. Very, very important. Another injection deal, but this time we're talking about trunk injection or injection of avocados with various products. Now, most of these products now are considered fertilizers. And I don't know, how many of you folks have injected trees before? All right, good. There's some experience. Now, many years ago, of course, the popular method was if you had a phytophthora problem in your avocados, you would drill a hole into the tree about the size of your finger, probably 3 or 4 around the trunk, and fill it with an unbuffered acid. Oh my God. And I'll tell you, the tree jumped. It really did. Well, of course it did, because, it's getting that acid. But long-term, not a good idea. This is called a chemjet injector. This is a part right now. It goes together. It has a spring in it. And you simply draw up the material, an unbuffered acid preferably, and it holds about 20 mils. And you probably can't see it from there, but it's got threads right here. So you take a 1/4-inch drill, you drill into the tree. I know this sounds crazy for people that aren't growers. You take this, screw it in, release it, and injects the material into the tree. And this is probably, in my estimation, the best way to do it. Gary mentioned buffered acid, the 02825. That is the way to go. That's what you want to use. That's also the acid that you probably would want to use if you're doing a foliar spray, or there's also a preparation where you can do a trunk treatment, which is interesting because you can use a very high concentration as a trunk treatment that they use, say, on oaks for disease problems in oaks. Actually is put on with a surfactant, can penetrate the bark. You essentially measure the canopy, and that determines how much you're going to use. There's a formula for all that, but very, very important. And of course, it's fertilizer injection, so it's got to be part of it. So there's a good picture of the ChemJet. It's a wonderful injector and very robust, very strong, a terrific product, I believe. This is what a trunk looks like with the 060. And so I would say you don't want to use that. The 060 is a great product to put through the water, though. 02825 buffered, less trunk damage. You can get a little localized damage, but generally it looks pretty good. And it works. You can see the tree. It takes about a year for it, but I've seen some trees that were knocking on death's door, and they came back after 2 or 3 rounds of the injection. And we usually do it during a root flush. So you're usually looking at June, July. maybe September, October. Some people will do it in March, April to increase fruit set of all things. Again, the roots, injection pressure from different, oh my God, years ago we had all kinds of people jumping into this. That's a great picture of injection. Moget fertilizer injectors, that you can buy these already preloaded. New tidbits and opinions. This was up at Brokaw. I think Gary and I were listening to this fella, that high potassium rates in the trees will repel bees from the flowers. So I know a lot of fertilizer suppliers sell their, bloom mix or whatever, and a lot of that has potassium in it. So the idea of putting on heavy amounts of potassium during bloom may not be a great idea. Should you inject gypsum? No, you can inject gypsum, but we also have another product called Thiacal, which is a clear liquid, much more soluble than gypsum. So we can always talk about that. Some people like to see the gypsum on the tree, but it's a lot of labor. If you try and put this through the system, it's very difficult. Dr. Crowley and I started a little partnership in business called I Want to Grow. Dr. Crowley was instrumental in developing the decision support tool for the California Avocado Commission, and then the commission dropped it, and Dr. Crowley wanted to keep it going. So if you do have a leaf analysis and you want to get even more detail on what I need to do, I've got some brochures over there you can pick up. But what happens is you simply input your leaf analysis. It goes off to Dr. Crowley. He does his magic on it. You get back a report that lists each element and its impact on productivity. So you know where to spend your money. You know your limitations. And the thing that I found from this is so very important is that a lot of people are over applying certain fertilizers, particularly potassium. All right, so that's it. Just real quick, I had a couple of things that I think are very important. One, we've got a lot of discussion on crop swap. And if you're not familiar with crop swap, that's where you can get paid to cut down some of your old avocados and to replant with brand new avocados. And that's a big deal. So keep that on your radar. And then there's another study going on right now called SALC2, SALC 2, coming out of the city of San Diego. And that's coming from a grant that was, gosh, almost $500,000 to try and figure out what is the state of agriculture here in San Diego County. And very important, log on to SALC, understand that, and please participate in all the different things that are going on around us. And so thank you.
Good afternoon, everyone. My name is Gonzalez. I'm with True Organic Products. True's been a company that's been around for about 20 years. We do solely organic fertilizer. I've been with the company about 4 years now. So they said they wanted an export in organic, so I actually invited down our lead agronomist, Dr. Ramy Colfer. He's countless years of organic experience. But I'm just going to go by briefly of kind of what True is and what we do. True's been around for about 20 years. This is our main facility. We have 3 facilities now up and down the coast. We have one up in Boardman, Oregon. So this is actually just a picture of our main facility in Helm, California. This is the majority of it. It's about 120 acres. You see everything there. There's the manufacturing facility, but all that raw product. And that's mainly what we deal with. There's a lot of raw products, a lot of chicken, poultry manure is kind of the bread and butter of what we do for a lot of our dry products. But a lot of our focus has been, especially on ours, is food safety aspect. We focus on food safety for all of our products. Everything that leaves our facilities has to be third-party certified by labs to make sure that when it reaches the fields that there's going to be no issues. And here is our research and development. I'm going to introduce you to Ramy Colfer, Dr. Ramy Colfer. He's our head of agronomy for True, and he's the one that actually has infield knowledge of all these products. He helped develop a lot of these products you're going to see today. The man is a wealth of knowledge, and if there's any questions, anything, he's the man to say.
Thank you, guys. Thank you for inviting us to present today. And we're happy to share our knowledge, but also very eager to learn more from you guys too. So this is our research and development / agronomy team, and Mike Mendez is head of food safety, and he does a lot of wears many hats. But who I work with closely is Asan Tusi. He's a soil scientist who's based in Helm. And we have two other agronomists besides myself, Margaret McCoy, who's based up in the Pacific Northwest, works with apples and corn, stuff like this, and Andrew Peterson, who works in the Central Valley on things like almonds and processing tomatoes and mandarins, etc. I always like to start out kind of going back to the basics on the difference between organic fertilizer, especially nitrogen, and how it works versus conventional fertilizer. And there was this paper that came out a couple of years ago that's been very useful in sort of displaying the differences and how plant available nitrogen becomes available in the soil with different organic fertilizers and soil amendments. The study was done by a group out of UC Davis, a very accomplished group that's done some really good work on nitrogen. What I'd like to show is they did this study and they looked at different parameters and they found that carbon to nitrogen ratios is a really good way of predicting how much plant available nitrogen you'll get from a organic fertilizer or organic amendment. And on the very top, you'll see graphs of for like yard waste compost, where you have a very high carbon to nitrogen ratio. And there, when you add it to the soil, you almost get no plant available nitrogen. And when I say plant available, I mean mineral nitrogen, so ammonium or nitrogen. So it's helping the soil, but it's not really providing fertilizer nitrogen to your crop. If you look at like manure-based compost, it's a little bit higher, but still quite variable, and somewhere between 15 and 30% of the nitrogen in that material becomes plant available over like a 80-day period. And in our area really is organic fertilizers, and those have a range of carbon and nitrogen ratios, but they tend to be smaller, and more of that nitrogen becomes available. Somewhere between 40 and 80+% is normal for that. And then lastly, they also looked at different organic liquid fertilizers, which all these things I should go back and mention are all kind of agricultural byproduct. They're materials that come from that are natural materials that are processed in a way that there's no chemical reactions. They can be heated up, they can be digested with enzymes, so forth, but no chemical reactions. So this was a graph. Actually, we made a proposal. You guys aren't affected down here, but in the Central Coast, there's Ag Order 4.0 that affected how much nitrogen growers can use, and it's a complicated story. State water boards come in, but we were able to get an organic fertilizer discount through the water board, the Central Coast Water Board, for organic amendments based on this study in carbon to nitrogen ratios and how much mineral nitrogen becomes available. And this graph just kind of shows like where the different types of organic amendments fall. So you have yard waste or dairy manure, beef type compost and the mineralization rates, manure-based compost, poultry manure-based compost, which is a little bit higher, your organic fertilizers, and then if you go to the very top, that would be where synthetic fertilizers sit, right? 100% plant available. So this is just kind of a summary of why the benefits of organic fertilizer for delivering nitrogen versus say compost, especially manure-based compost. Manure-based compost can come with some risks of salt if you use high rates, especially potassium or sodium chloride, and there's also a low amount of plant available nitrogen that comes from that material. And there's also possible risks of like adding weed seed and maybe even a human pathogen if it hasn't been properly composted. And even in that process, it's not ideal. For organic fertilizer, we have a kind of a food processing type kill step process with all the steps that are necessary to qualify for LGMA compliance. And we're the only organic fertilizer company that's ISO 22000 certified, which is kind of more of a food company type registration. So going from there, the other thing I'd like to point out that's really different about organic fertilizer versus synthetic fertilizer is the amount of carbon that we're adding to the soil with our products and with other organic amendments. So for instance, if you look at compost or a cover crop, and this is a slide from Richard Smith. He's a farm advisor up in Salinas Valley. He's now retired, but still working, though he's retired. This just goes to show how much carbon you could add with these different organic practices. And organic fertilizers is very comparable, but you're really adding, thousands of pounds of carbon to the soil each year with these practices and inputs. And what does all that carbon do? The two main food sources for microbes in the soil is organic carbon and organic nitrogen. And you add those things to the soil, they're gonna you get more microbial activity. You're gonna build up soil organic matter, and that's really gonna improve your soil quality and your soil health. And this is from the NRCS, just going through all the benefits of increasing soil organic matter, and many things, that are very important for avocado growers, like increase nutrient holding capacity as well as increase water holding capacity, friability, but also you have less likely to leach things like nitrogen, and have runoff, during a storm event. The other real difference too is the amount of microbial activity that you see in the soil over a long-term period of adding organic amendments under like organic farming practices. And this is a study that soil scientists I work with, Hassan Tusi, did with one of our large customer growers that farms organically and conventionally. And this is all in the same area, side-by-side ranches, some long-term organic fields, comparing it to a conventional field. And these fields were all sampled when the field was when the fields were fallow before they went into vegetable production. They all received long-term use of organic fertilizer product we have, 851. And what Hassan found in this study is that if you look at microbial biomass, both in the form of nitrogen and carbon, that there was dramatically more in the organic fields compared to the conventional field. And this was even more so for the field that had 2 rotations per year, which had more farming going on per year, more turnover, more inputs going into it. So now I'd like to review some of our products that we have. True has many, many products, and it would kind of bore you to go through all of them. But I wanted to hit on some key ones, and including one I know Leo mentioned, one that he got True to start manufacturing years and years ago. That's a very popular product and very well suited for avocado production. So just to show you, this is a big range of our products with different percent nitrogens. Generally, the higher percent nitrogen products will have a lower carbon to nitrogen ratio, which means they release more. There's more plant available nitrogen that's available during the process. And then those are the percent carbon. So all these things have, somewhere between 20 and almost 50% carbon. I was just going to run through some key materials that might be very good for avocado production. This is probably our best dry fertilizer for delivering nitrogen. It's a product that's based on meat and bone meal, which is a real important material for us, and also seabird guano, which is also a very important material. And what the seabird guano doesn't, it has more plant available nitrogen, and so you get kind of quick release as well as slow release. So the meat and bone meal, everything's in sort of protein form, and it needs to be broken down by microbes before it's released. So this product's really going to give you a fast and a slow release nitrogen source, and it also comes with slow release phosphorus and calcium from both the seabird guano as well as the meat and bone meal. 1028, I think, is one at the very end of this talk, I do have some suggested programs for organic avocado production for the Southern California and for Central California. And one of the inputs on that program is 1028, just because it's highly available nitrogen, but it also is a very good potassium source, avocados, and it's a good ratio of material. Yeah, it also contains feather meal, which is our sort of slowest release nitrogen source that we use, and it's a really good product. Just to kind of go through some other materials we have that are like 1052 is meat and bone meal with a little bit of SOP, and it is really good at delivering nitrogen, and it's our best priced low carbon to nitrogen ratio product, and it's used a lot in things like vegetables. If you're looking for a product that's very specific to just nitrogen, we have this blood meal product that 0.5, 0.5, which is blood meal, poultry manure, and feather meal, and it's a very good product if you don't, if you have plenty of phosphorus and potassium in your soil and you're just trying to deliver nitrogen. This is a product we'd sell in say strawberries quite a bit. 662 is a lower nitrogen product that's probably our most popular product in leafy vegetables, an area that I've spent most of my career in. So leafy vegetables need something that's not too hot, not too cold, both quick release and slow release nitrogen with a lot of carbon, and 662 is really good fit for this. And I mentioned these to you guys too, because they are potentially good fits for avocados just based on their NPK ratios and just due to their popularity in terms of our volumes. They're very well performers. 7.5, 5, 7.5 is another dry fertilizer that we sell that's sort of a more economical version of 10-2-8. So it's got a very nice balanced NPK profile. It delivers both quick and slow release nutrients to the soil. And this will be the last mainstay product. 851 is probably our most economical, most widely used product in leafy vegetables and maybe vegetables in general. It's widely used in organic processing tomatoes in the Central Valley and broccoli production, celery production on the Central Coast. And it's again, a meat and bone meal, poultry manure, feather meal based product. I also want to mention this one. I know Eddie mentioned you guys fight salts. You're always trying to get more calcium. This is an experimental product we've developed and we've found, and it's got some of our good organic fertilizer ingredients combined with elemental sulfur, high soluble gypsum. And what we find is when you put it all in a pellet, it's like you put it in the soil. It's like you're providing all this microbe food with these organic amendments, and a lot of things happen more quickly. The elemental sulfur will convert more quickly, and the calcium seems to really show up quicker. So yeah, it's still a new product for us, but it could be a good fit for avocado. Going back, to that UC Davis study where they looked at different carbon and nitrogen ratios, percent nitrogen materials, and how much plant available nitrogen comes out. This is a study we did in a grower field under grower management practices, and with a number of our different organic fertilizers that I just reviewed. And what you see is kind of just like what they saw in that UC Davis study. The higher percent nitrogen materials, like 10-2-8 or 10-10-2.5, those were our best performing materials in terms of delivering nitrogen, and those lower percent materials, gave less. From there, I was going to go and discuss our liquid products. So this is not a full list, but these are a lot of our common liquid products. And I put this up here too because it really shows the amount of carbon that comes in these products too. I think most people think of liquids, they think of solubility, but they don't really think of carbon. And I think our products, are really full of carbon, even the liquid products. So, again, we're going somewhere between 16 and 24% carbon, which is, comparable to compost. And I think that's good to think about too, because these products could, they're good in organic systems, but they could also be a really good way to add, some organic material to your soil through your drip irrigation system, and even a conventional system. So building up soil health. And I think, definitely some of these are already used. I think like 10-2-8 is a real high carbon product that's high in molasses. It's something that's pretty commonly used in conventional strawberries, for instance. I was just going to mention a couple of these. 422 is it's probably our biggest seller. It's used in a whole range of different cropping systems, including a lot of tree crops. It works very good in like organic almonds, and it's all plant based, and it comes with low amounts of salt, so you can even use it at very high rates without any risk of adding too much sodium and chloride. It's a really interesting product. It even comes with if you do like a fulvic acid test, there's a lot of a high fulvic acid percentage in here, like somewhere around 30%. And that's plant-based fulvics. It's not linerdite-based fulvic, but they're still very biologically important. 512 is a mixture of fish and plant-based ingredients, and this is probably our lowest cost price per unit nitrogen material. It's also very popular for us, but it does come with a little bit additional sodium, so it's something we wouldn't recommend using at a real high rate. And all these products, in addition to the ingredients, they also they go through this pasteurization step, but I know if we test them, they're kind of loaded with microbes, sort of heat tolerant microbes that are still in them, bacillus and other types of materials or microbes. 700 is a product that's based on soy protein hydrolysates. Soy protein hydrolysates are very interesting because they really are popular, especially in other parts of the world. As biostimulants that are used a lot in conventional agriculture even. And they can work at low doses in helping shoot and root growth, increase leaf percent nitrogen, and have reduce stresses from the environmental conditions like salinity and heat, much like some of the other biostimulants like kelp and humic. But they're also a very potent organic fertilizer. And this is just one example of a study. A lot of this work's been done in Europe, just showing how even a very low dose of, this is, I think, a 0.5 to 1% dose of soy protein hydrolysate can increase root, shoot, and leaf percent nitrogen levels in tomato. True, we have our 700, but we also have some other blends that are based on these real high levels of amino acids that are quickly available because there's less time necessary to break them down by microbes, but they are still based on organic nitrogen, not like ammonia or nitrate. And we have a 611 that's fish, soy, and corn, a 522 with soy and corn, and also a soy that's just powder that you can add and solubilize yourself. The 700 is very popular for us because we do, even though it's plant-based, it is possible for things like salmonella to persist in plant-based materials. So we put it through our pasteurization step for food safety. Just another study that was done on these products by farm advisor Richard Smith in Salinas Valley. This is in romaine lettuce. The first graph just shows a comparison of these products versus UAN 32. And you can see like the overall yields was very comparable to what you'd see in UAN 32, so similar efficiency. And in fact, if you look at the right side, it's the pounds of nitrogen that were taken up in the crop, and the highest nitrogen use efficiency was at 700, the soy, even higher than UAN 32. There's a few new products I wanted to mention also that that might be of interest. I know phosphorus is not a huge demanding issue for avocado, I guess, very precise use, I guess. But this product comes with a low pH. It's based on fish, and it's all these liquids are very useful in drip irrigation systems, and it could be something that could help kind of buffer soil pH in the root zone too. And this is not a real new product, but our agronomists of the Pacific Northwest did a wheat study, and adding somewhere between 10 and 15 gallons as a pop-up application on wheat, we saw somewhere like a doubling of root and shoot growth from that application. I know potassium can be real important in avocado, and this is a new potassium product that's low in salts, comes with a nice mixture of biostimulants too, and we've seen this can work really good, and even combine it with things like KTS. We did some studies combining it with KTS and found that it actually, the combination seemed to work better, especially at like a 80% KTS to 20% True BioK 107. You saw sort of better potassium response and also less salt buildup. And this is a trial we did in strawberries last year with this product at 15 gallon per acre rate combined with some other true biostimulants. And we saw like a nice increase in potassium uptake as well as an increase in the number of fruit per plant in strawberry. One thing that also can be important for all crops, avocado included, is calcium. This is a soluble calcium product we have. It's a chelated product. It's derived from calcium carbonate, but it goes through this process where we chelate the calcium with the right size soy amino acid mixture, and so the carbonate sort of goes away as CO2. So it's really a chelated calcium material that's very effective at delivering calcium. There's other ones like it that are similar on the market, but it's we've seen good results with this. The last liquid I'll mention is our Pro 10 Plus. It's sort of a laundry basket full of different biostimulants, and we try to pack as much as we possibly could into this liquid, so it's very dense. It comes with it's got a molasses base, but we have soy, corn, and fish protein hydrolysates. We have a very high dose of humic acid. We also have a very high level of kelp extract we add. like 6%. And then we have micronized shrimp shell and betaine in there also. So this one, we've seen very good results with this, and we're getting some momentum. And I think the other thing about True is we try to price all these things at a level that might be expensive for conventional fertilizers, but we try not to try to keep them affordable for organic growers. And this was just a trial we did a couple of years ago in some real high quality commercial organic celery. We did 3 fertigation applications at 10 gallons per acre and saw a nice increase in plant weight, even though the quality of the crop was quite high in the grower field. Very quickly, just to finish, we have these newer these soil health products, not necessarily delivering nutrients, but we're really trying to improve soil quality, improve soil health. So these mixtures of organic amendments that with real key ingredients like shrimp shells, high soluble gypsum, and humic acid, and combined with some of our traditional ingredients. But we're seeing really interesting results from these materials. I'm not going to go through all the information now because it's we have a lot of good stuff, but we're seeing, increased nutrient uptake with these. We're seeing real increases in microbial activity in the soil, and in certain cases, we're seeing reductions in soil-borne diseases. So it seems like the increase in microbial activities outcompeting some of the soil-borne pathogens that are in certain systems. Having this high dose of calcium in this product, we see this was in an organic blackberry field. Compared to a more standard organic fertilizer program, there was much higher calcium levels throughout the whole season. This was despite the fact that this is a crop that's where they're adding a lot of calcium through the whole program during the year through their fertigation. Another product we have in this category is what we call complex carb pre-plant (CCP), which this product is really we're trying to bring. It's almost like a food for the microbes. So it's protein, sugars, starches, fats, fibers, and even some biochar all in one material, one product. And it's trying to create a very favorable environment for microbial activity. And we've done trials like compared to like really high rates of compost, and we see a lot more microbial activity from this. We've seen it really jump up carbon cycling, especially. We did this one study that I wanted to maybe just real quickly go through it. So this is just a cartoon version of food web in the soil. Mostly what we're dealing with is fungi and bacteria on the bottom, but protozoans are sort of like the small predators in the system. And in most agricultural systems, you don't see very many protozoans. But in this study where we used a high dose of CCP in this organic raspberry system, we had a tremendous amount of growth. And really, the blue bars are no addition to CCP. The orange bars were sort of the general area, and the gray bars were where it was concentrated at the base of these beds, these listed beds. And what we found is there's like a huge spike in microbial activity with the addition of this product, and we saw a big increase in protozoans. So basically, predators coming into the system, really developing this food web with this product. So pretty interesting. And this, we also saw going towards a carbon more. If you look at the bacteria to fungi ratio, it increased. So you're getting more fungi, which is really important for building up carbon in the soil. Lastly, we've done some conventional applications. This was CCP versus a shrimp waste product, experimental product we had in a conventional strawberry field, and we saw real bad macrophamina at the end of the year. And where we added even the low dose of these materials, we saw a real reduction in the amount of dead plants from macrophamina. And then we just have some pictures here of the grower field, and this is the area that with this the complex carb pre-plant. And then there's just a drone image where you can see a lot of death, and then the edges there are where we applied those materials. So I have some programs which I don't think I'll be able to get into, but I would like to be able to share these with you guys in the future if we'd like, but really based on our dry products in the winter, and then adding liquids throughout the growing cycle at opportune times.
Those of you that are online, we want to apologize. Our tech person that was supposed to be here an hour early to set all this up, her car broke down on the way here. So obviously we have technical difficulties. So Greg, you want to ask the first question?
Yeah, here we go. What advice do our speakers have regarding the use of wood chips or mulching under our trees? What role should mulching play in the replacement of nutrients lost to harvested fruit and the annual leaf or fruit drop?
Since you were talking so much about carbon to nitrogen ratio, you wanna take
I'll
this to
kick it
start?
off a little bit, yeah. So wood chips, you know, I think if they're left on the surface, not incorporated in soil, they're very slow to break down. They're also very, they're full of carbon, like 51 ratio, 80 to 1, but that carbon comes with, it's very high in lignin. So it's very slow to break down. But as it does break down, it will compete with your crop for fertilizer. So it will, you might have to add additional nitrogen to compensate for that with the wood chip becoming, breaking down. But it does help with water holding, capacity in the soil, right?
Yeah. Eric, how do you feel about wood chips?
Well, you know, I think some of the growers tend to overthink things, and we're in the midst of a 3-year healthy soils program right now where we have to put out between 8 and 10 tons of wood chips on one side and compost on the other, and it's a lot of work. I would say that, yeah, sometimes you benefit from it, but on a larger scale, it's very difficult to do. And what I would suggest is getting a good soil analysis, finding out if indeed you need something like that, and then perhaps looking at other methods to try and supply, you know, the benefits of wood chips if you think there are some.
All right, let's try the next question. Do our speakers have any suggestions for a new farmer trying to budget for the development and deployment of fertigation hardware and control systems? Any recommendations on design firms with for designing avocado irrigation fertigation systems?
Eddie, you guys sell irrigation, why don't you go ahead and handle this one?
Well, we do sell those products, but we don't do design. And the reason for that is you can look at our grove. But I would suggest that if somebody's interested in that, whomever they decide on contacting, that the person has certain credentials, that they have, you know, a background or some type of degree in engineering, or they certainly have a track record of putting in systems that work according to the grower's expectations, but not to get too overwhelmed with automation. I think that automation is a great thing, but I don't think you need the extreme automation that a lot of people look at where they can simply look at their phone all day and try and grow avocados, because that doesn't work.
I think that's all for our current.
Any questions from the crowd?
Info on that crop swap. Where would I find more info now?
Info about the crop swap.
Oh, certainly. I don't know that much about what's happening right now, right here, but I can tell you the way the program is supposed to work. And I believe that Rancho Water is the one that's kind of the head of all this, and then it trickles down, no pun intended, to the different agencies. And I believe that Rainbow and Fallbrook and perhaps Oceanside are kind of at the head of the spear right now, and hopefully Escondido is going to get on board. But the idea is for avocado growers is that if you have old trees, that you would be allowed to cut those trees down and to replace those trees with more modern tolerant rootstocks like the Deuce or some of those, or some that are more tolerant to salinity, and that there's a variety of costs that they would cover. Perhaps the trees, the labor, moisture sensors, compost, and upgrades to the irrigation system. So it's a pretty exciting deal. Now, they've been doing this up in Rancho, California, I guess, for a year or two. And it originally started to where they would have avocados and they would transition it to something like grapes or citrus. But now they've decided that maybe we can do something down here. And I had talked a couple of years ago to our water authority down here about a program. And I said, why in the world are you guys not looking at something like this? And they had all the excuses, but my understanding is that the agencies that are going to participate have to be signed up by the end of the month. So I would suggest calling Rancho Water. I think there's a fellow up there, Justin. I'm sorry, I don't have his last name, that you could ask about, or go online and maybe take a look and see if you can find anything about it.
There's another question here, or yeah, okay. There's a question here about carbon. It is, I've never seen carbon tested in a soil analysis. Is there a way to do that?
I could start, soil organic matter is a good, a large component of soil organic matter is soil carbon. And there's also a total organic carbon, which is something you can have most of your labs measure. I know we do that quite often. And then there's other forms of carbon you can measure, things like soluble carbon and labile carbon, stuff like this. Certain labs will do. I have more information specific.
What carbon on these tests is soluble? Does it tell you what's soluble? Is it a hot water test? Is it a nitrogen breakdown test, a carbon to nitrogen ratio? I mean, if your carbon to nitrogen ratio is off far enough, that carbon's tied, right?
Right. Yeah. I don't know the technical answer to that, but yeah, I know you can get those measurements, and I think the soluble carbon is more available. Yeah. So.
Okay.
Is there a difference in timing for organic applications of fertilizer compared to conventional?
The question, so that you can hear us online, is there a difference between timing for organic and conventional? You want to start with organic?
Sure. So you are relying on this biological process to break down your fertilizer before it becomes plant available. So you usually want to be at least 2 weeks ahead of time before you have the crop uptake needed for that fertilizer. So I'd say it's good to always be ahead. Also, because it takes a while for things to break down, it's best never to get behind, because once you get behind, it's really hard to fix with organic fertilizer. So you kind of, with a lot of things in organic farming, you got to prevent the problem before it happens. And I'd say the other thing is when the soil temperatures are cool, or making sure that the fertilizer is in the soil, all those things are very important. If it's cooler, you need even more time. Yeah.
I also think it's important during your presentation, you were breaking out what is seabird guano and what is feather meal.
Yeah.
You might want to explain the difference in release on those two products. Feather meal is extremely slow,
Right.
And seabird guano releases almost like a conventional fertilizer.
Yeah. I think that's
pretty much it.
Yeah. And there is some differences. I mean, like in those graphs, that if you have a warm soil, they all kind of release same time. But some of the higher nitrogen materials will have more of an ammonium spike. So they can, if you have a real high dose, they can be more phytotoxic.
I just know that when people use straight feather meal, they'd always come in and complain it wasn't working.
Right.
And I just go, wait, just wait, wait. I mean,
Yeah.
I'm sure you've seen the same thing, Eddie.
Mm-hmm.
And then conventional, how soon before you want to see a response do you want to apply a?
Well, there again, it depends on what nitrogen you're using, what time of the year, the soil temperature, and all those things. But generally, I try and recommend a fertilizer that has at least half the nitrogen in the nitrate form this time of year. And then as the soil temperature warms up, then you can go to other forms of nitrogen. But I've seen some trees, particularly young trees, color up within a week or two of a calcium nitrate application. So it can work very quick if the tree's healthy.
Okay, there was a question on the Zoom about foliar feeding avocados. It was just can you talk about foliar feeding avocados?
Well, I can say a little bit about it because we've done a lot of that. I think if you talk to the university, they'll say that the absorption is very, very limited, maybe on the new growth, and that's about it. Years ago, people used to put on a lot of foliar products, but primarily it was zinc, and they would use all types of different zinc products from 10 pounds of zinc sulfate per acre put on by aircraft to a variety of different zinc chelates. And the idea was that when they would test for it, of course, in the laboratory, they could get a spike, but it was because the product was sitting on the top of the leaf. So the only thing that I'm confident in being able to actually benefit from a foliar application on avocados is phosphorus acid. That's the only thing. Now, I'm not a scientist, so I'd have to defer to you guys, but I think that that is about the only product. So then the question is, can I add something to that phosphorus acid that's going to act as a carrier into those leaves? And that I can't tell you. I can tell you that once that new growth is hardened off, that waxy cuticle is just about impossible to get anything through. But that's my experience.
I'd agree with your experience. I feel the same way. Yeah. The university's done all these studies, and again, for years, people were applying zinc, and our zinc levels were going up, but they still had round fruit. And phosphorus acid, I have seen trees that have slight Phytophthora symptoms jump out of the ground once they have a phosphorus application that's foliar. So I'm assuming that there's a reaction there, but for severe trees, it's really hard to get the product in to the leaves. So for the most part, I try to avoid foliar applications.
I can't speak to foliar applications for avocado, but I know some of our products are very effective as foliar materials in other cropping systems, especially like those soy. Soy is very low phytotoxicity, and you can see a very quick crop response within days or a week. And some of the other materials like the mixtures with kelp and humic and soy molasses, they can have pretty good crop response in vegetables. Yeah.
Do you have any fulvic products at this time?
Not linerdite based. I mean, yeah, they do contain fulvic, but not, mostly plant-based fulvics. Yeah.
Plant-based.
Yeah.
You want to explain the difference between fulvic and humic?
Fulvic acids are a smaller molecule, and normally when people talk about fulvic acid, it's linerdite based fulvic. Fulvic and humic are from a mine product that has very unique molecular properties that enable it to chelate nutrients and also feed microbes in the soil. But fulvic acids in particular are very good at chelating nutrients and enabling plants to move them around.
Commonly used for organic citrus. Works great for getting product into a citrus leaf. Don't know much about avocados.
But we love to learn, so.
Yeah. Yes.
One of the biggest problems growers have been for a long time has been root rot by chocolate. And we do have a product obviously that you can use for conventional. Do we have anything for organic? Other than I know repeaters.
Yeah, for those online, what Jose is asking is, do we have an organic Arondis type product available for avocados? And nothing that I know of at this time.
Big no.
Yeah, big no.
Good drainage?
Well, again, people play with carbon. A high carbon diet makes Phytophthora struggle. Straw with an organic matter on top of it, it's very common to apply straw, gypsum, and Greg Partita had his method of high carbon, which is straw, chicken manure, and then on top of that, he put a bag of gypsum on each tree, and it worked. Phytophthora is a soil algae, not a fungus. It's actually an algae, but it has to survive in the soil, and if it has antagonistic fungi and algae, it will struggle. That's about the only thing I know for organic. Those of you that have not used Arondis and your trees are the old 1 to 5 scale, if you're 4 or better, the trees are not too far gone. Groves I've seen with the Rondis, have been excellent, and I no longer sell it, so I'm not biased. Yeah, go ahead, Gary.
Well, one of your organic products had a kelp product in it. And we had some trials out where we were spraying directly on the blooms of avocados and getting quite an increase in fruit set. Have you ever tried as a flower spray, bloom spray on anything?
Gary's asking about kelp bloom sprays, and you can go first, then I know Eddie's got something to say about that too.
I don't have direct any.
Okay, Eddie's got a real good knowledge about this product.
Well, I don't know. I have some knowledge, but I think with Gary's trial, at least one of his trials, he was using some of our product, and that particular product was a kelp derivative, but it was through a fermentation process where the product actually was, I guess you could consider it a biostimulant. So it actually was somewhat different than just buying kelp and putting it on, or putting it in water and spraying it on. It really had its beginnings from a EPA registered growth regulator. So that gave it, some real teeth, and that may have been why we got better results. But I think what happens is, and we didn't talk about this in our discussion much, but it's a whole question of biostimulants now, and that's huge. It's a huge marketplace, because I think some of these folks are starting to see that there is some promise with some of these products, because now I think they're a little better regulated than before. But I would suggest to some growers, again, the fulvic acid fits that, the kelp fits that, all these different preparations that are out there that could be considered nutrastimulants fit that, but it's not something that you're going to put on and really flip everything. Now, what Gary was talking about is to put it on as a bloom spray on avocados and targeting the bloom, which makes a lot of sense, because there may be some benefit to that, or adding higher levels of boron directly to the flower, and some of the work that Carol Lovett did with low-urea and so on and so forth. But make sure you know what you're doing so you don't combine some of these things and cause a problem. But don't look to that as the basis for your production mechanism, because it's only a small part of it. It's just a detail. But also don't be hoodwinked by saying, well, I'll buy some kelp and spray it on, because there's kelp and kelp and kelp and kelp. So
I couldn't agree with Eddie more. He's 100% right. There is no panacea for growing avocados. I remember a grower telling me, I've done this extensive report, and all I have to do is get my copper up 2 parts per million, and I will double my production next year. And I'm like, if you add another acre-foot of water, it would really help too. So there are no panaceas. It's good long-term cultural care. And I think we've learned that good long-term cultural care requires sometimes a conventional grower has to use an organic product just to get the soil back up and running like it was when we planted. So I think we're learning that as time goes on. And I'm a conventional grower, and I use organic products all the time. I use the 10-2-8 on my wheat trees. And I also need to use the 10-2-8 because I also mulch my wheat trees, so I know they need more nitrogen. So I still have wheat trees, but not as many.
I would mention too, some of the benefits we've seen from our biostimulant product, which is a mixture of a whole bunch of different modes of action. But we've seen increases in nutrient uptake across the board. Sometimes we've seen it where it's been focused on nitrogen, but also NPK. And we had one experience where we had it in a ranch organic raspberries where it's getting hit by phytophthora early. And the area that had the biostimulants, the plants did better than the area that didn't. So it didn't fix
competition.
It didn't fix the problem, but it enabled the plant to compensate for the disease a little bit more.
Yeah, I just wanted to get your thoughts on like ground cover to reduce
soil erosion. My grow's on a slope, and with these rains, there's so much topsoil.
Okay, as a grower that's had both young trees and mature trees, when they're young, you've gotta have it. On these hillsides, you've gotta have, and it's tough. You put down straw and, I'm sorry, the question was, growing ground cover around, young
Yeah.
plantings on hillsides.
Or it's anything to, mitigate.
So number one, if it's a new grow, you have to straw where the mains were put in, main pipes, because first time you get a rain, the erosion will kill you. And you will notice that wherever you straw, you get weeds, because the reason they harvest the straw is to get it out of the field. The crop was the grain, but the grain fell in, and oftentimes here we have barley straw and some wheat straw. So you've got some growth then. And then what I do on my grove is when it was young, super young and just planted, every other row I actually came in and planted a mixture of rye and barley for erosion purposes, every other row. And then as the growth matures, now you're fighting weeds. Hopefully you'll have enough coverage where you won't need a ground cover. And the other thing is I've tried white clover, strawberry clover, all the clovers that the universities say do not require water, and they're wrong. It requires more water than I want to spend watering. I'm sure you've tried clovers too, and you can grow them, but you can't grow them well without putting a rainbird out there. And in August in Temecula, yeah. So ground covers are good for the winter. In the summer, you just can't afford to water them.
Yeah, Leo's right. We also, for years, because we're on a pretty severe hillside, probably around November, we used to order the load of straw, and then we'd go out and throw out some annual rye and then throw the straw over it. And with the first rain, it would sprout through the straw, and it was nice because that annual rye would disappear, around May or June. It would just phase out. But I think you have to be careful too, because if you have a permanent crop out there and you have quite a weedy condition to control your erosion, you can miss a lot of rodent problems. And then also the idea of stealing water from your trees. The cover crop can take a tremendous amount of water. Plus the guys don't want to walk through it because you never know what you're stepping on. If you have uneven terrain, it makes it hard. But 100%, you've got to hold that soil, because once that soil moves, very hard to put it back. The other thing that's pretty handy occasionally, especially with this year that we had, are using straw wattles in strategic areas. And being able to throw out a straw wattle, they're relatively inexpensive. That, it looks like one of those round hot dog things. And they work very well to divert the water or channel the water into places. But it really comes back to the design of your grove again, on putting those roads where you can on the contour and trying to do some of that work ahead of time.
Cool.
One more.
Yes.
In looking at a dry fertilizer label, what's the import or significance of the percent of humic acid?
The question is, on a dry fertilizer label, what is the importance of the percent of humic acid?
Like my label says 10%. Is that good? Is it bad?
I'll let a humic acid handle that one. We're skating on thin ice here.
I mean, percent's always a little bit dicey because you could always add more, if you think about rate per acre of a material. But I'd say 10% is a pretty high level for humic acid. But I think, I don't know if there's one right answer for that.
Yeah, I think the big question is of that 10%, what's available? And humic acid, like you said, it's limonite rock that's ground up, okay? And is it going to be limonite rock forever, or has it been activated to a point where it will break down? A lot of labels you have to be really careful. For example, iron and zinc. If you get zinc oxide, That's what mom used to put on our noses when we were kids and it stuck. And the reason she did that was because it was water soluble. So a day at the beach, it wouldn't wash off. Well, if it's water insoluble, it's not going to release in your avocado grove, right? So the source of humic acid is as important as the percentage. Wouldn't you agree with that?
Yeah, I mean, there's a lot of variability in quality for sure, and I don't think there's a good way to test. I mean, there are like the AOAC method of testing. That's like the gold standard for testing, but even then, I think you need someone who has some expertise in it.
Thank you.
Also, a little secret in fertilizers, and we're all aware of it. Organics, it's a little different, but in conventional fertilizers, to try and separate yourself in the commodities market, you have to dress them up. And so all these added products, which make it a different fertilizer, many times are not even worth whatever's printed on the label. And whether it's 1% or 2% or 3%, I just don't know too many people that say I have to have that at that percentage, and you have to have that ingredient in my fertilizer program. Many times, unless they have their soil tested, they don't even know if it's necessary. But what comes around is, through different publications and promotions and things, it becomes the product of the week. And so are you going to pay 25% more for a standard fertilizer product because that ingredient's in it? I don't know if you really want to.
Thank you.
Great. Is that
Any more questions? One more.
It's amateur question, but this is the first time I really heard about plant available nitrogen. Can you ascertain that from the fertilizer you're using, or did I completely miss that?
Sorry, can you repeat the question?
The question is plant available nitrogen versus non-plant available nitrogen. I'd say it really comes down to plant available nitrogen is mineral nitrogen. So it's in the form of ammonium or nitrate. Nitrate is what most plants take up. There is some evidence that, like amino acids can be absorbed by plants directly, but for the vast majority of plant available nitrogen would be nitrate, but also ammonium. Yeah. Any other?
so just in simple terms, because I'm a simple person, urea is not available to a plant.
Okay,
You
great.
need nitrosomonas and nitrobacter, which are two bugs that eat it. And there's this thing called the nitrogen cycle. And I can't remember all of it, but yeah, the nitrogen cycle. So the nitrogen has to break down. But the key is you want it to break down before it leaches. So that's why Eddie was showing small amounts frequently is a good idea. Small amounts of urea frequently works really well in a grow. You put a whole bunch of urea down at one time. If it's cold, you may get very little of that into the tree. And that's basically what you're talking about. And it's nitrates, how it's available, but how do you get to nitrate? And
Right.
some products that are nitrate, you have to be very careful with because they leach extremely quickly. That's why all these new regulations.
Because the fertilizer has urea nitrogen as well as ammonia.
Right. That's a common combination. The ammoniacal is like this. The nitrate goes first, ammoniacal second, and then urea will break down over time with bugs.
As it interacts with the organism,
And
organic matter.
Soil, yeah.
yeah, with the soil. And healthy soil, it'll react quicker.
Thank you.
Let's give it up for our panelists.
Right.
Again, folks, sorry for the technical difficulties. Don't want to walk off the screen here. Thank you to our sponsors, our seminar sponsors, and our foundation sponsors. And please join us for our next seminar, which will be in the field. So none of this, hopefully,
No technology.
No technology. Come and put your boots on and join us and get your feet dirty. All right, thank you, everybody.
Thank you.